Dr. Jin-Yuan Liu, President of Taiwan Society of Deep Ocean Water Resource Application, Chief Professor of Tamkak University. Thank you. Please, you have a floor.
First of all, I would like to thank you to have this opportunity to give a talk in such important conference. We had the first talk about marine policy, the second talk about marine technology. Now let's talk about the ocean itself. And ocean is full of water, in particular, deep water. The theme of the conference is Ocean Planet, which is a very good name because Earth is not a good name for our planet. It's supposed to be the ocean because 70% is occupied by water. So my talk is about the R&D of the renewable water from the deep ocean. And in fact, there are other societies which also have developed and also talk about the topic about the use of the utilization of the deep water. But in our community, in this community, perhaps less. But I think some of them we have heard about, such as OTEC, something like that. So I would outline. This is the outline of my talk. It's about, I will have a very basic talk about the deep ocean water, abbreviated DOW. And then we have a industrial development and applications of DOW in the world. In particular, I'll talk about the Taiwan development on DOW. Not because Taiwan is doing well. In fact, we are facing difficulty. And maybe it's we are also at a critical stage, so maybe it's a good lesson for those countries or area who want to use the deep ocean. Okay, so I'll speak Taiwan part. And near the end, come back to the original use of the deep water about OTEC, and concluding it about what is the future of the DOW. Okay. So what is the DOW, or DSW anyway? Well, have some textbook info about the ocean temperature distribution, which the main part is stay at cold, 4 degrees below 1,000 meters. And above, there's a layer about 2%, okay. About 2% surface water, 80% is ocean, it's in the picnocline, which change fast. Okay, the temperature, salinity, and density change fast. And then we have DeLong. Okay, this is from Garrison's book. Okay. Other than this, we have in fact, we have only one zone, one ocean wall, because all zones are connected, and all oceans are connected by this so-called conveyor belt. Okay, so it's the surface water, and going down North Atlantic, and then pass through, going to the South Hemisphere, pole area, and come back to Pacific, and then come back to Atlantic. So this connect all oceans together, and also mix the zones. Okay. Also about the water below 200 meters. Okay, it's the light. Okay. The blue penetrates most, but it's only about less than 300 meters. So the light relatively shallow, except blue to 300 meters. So below 200 meters, this photosynthesis process is less active. Okay. So the temperature below, the water depth, the water below 200 meters is characterized by low temperature, purity, and abundant nutrient and minerals. Okay, which is the main reason we use this deep water. Okay. So the definition about and the characteristics about the DOW, well, in fact, there's no so-called definition. It just depends about what is the water at the depth where the temperature is low enough and the quality and the content satisfy the needs for various applications. Because that would be a good way to say the deep water, because still there's ambiguity for people to argue. When I say the 200 meters is the deep ocean, but for oceanographers say no, it's at least 1,000 meters. But it depends about what you need. Okay, if you need the low temperature is low enough, that'll be good enough. So this is the characteristic of the DOW. Okay. Also, it's renewable in the sense we just have seen that the conveyor belt will bring the surface water into the depths and come back to the surface. And so when you use the deep water, you never use, it's always have there. Okay, so it's renewable. So based on this characteristic, this application, has been developed in past 30 years, starting from United States, Japan, recently in Taiwan, Korea, and also China. Okay, so the cold energy, actually, when we get a deep water cold energy, it goes through heat exchanger. Well, it's original, the cold energy can be used to get the electricity through OTEC, okay, and can do refrigeration, low temperature agriculture, air conditioning, okay. And then if you have a temperature control system, it can use to grow algae, fish farming, agriculture, and spa, etc. Okay. Those waters which you go through the water desalination can be used as drink water and also being used as a food addition, cosmetic, health product, and salt itself. So it's an industrial, it is a chain of industry, an industrial chain. Has three, the parts. The primary industry would have start from the cold energy part, okay. And as I just said, that low temperature agriculture, mariculture, okay, is very important, okay. And I'll talk about next in the second, in another slide. And the tertiary part is about its expedition activity, tourism, and celebration event, and so on and so forth. And those are supported by the electromechanical equipment and electronic business, printing, packaging, marketing, and design energy. Okay, so this is a full industrial trend. And just for water itself, it can have a low temperature. When it's the low high nutrition, you can grow shellfish, okay, shellfish, and then algae, then general particular, okay. And for secondary industry, okay, it is the most the use for refrigeration, air conditioning, spa, drinking water, and wine, drink, foods, fermented foods, cosmetic. Okay, this is actually the most right now. At its stance right now is industry part gaining the most profit from here. Okay. So where can get deep water? Well, in theory, those area or country area, bordering the ocean and the ocean or the sea, the deep enough, okay, you can get a deep water. Okay, but if you have a relative slope is relatively low, then you need a long pipe, okay, the pipeline. So the area which is best is it's in the area which have a very shallow, narrow, the continental shelf, such as in Taiwan. Okay, this is in Hawaii, Japan, Korea, and all this area go into here, particularly in Taiwan, actually in the east coast of Taiwan. When you go out like 2 kilometers, you go into a depth of almost 1,000 meters. So it's a very good place to get, the deep ocean water. Okay, and many other locations. Okay, So this is countries or areas, which has now developing the industry, utilize the DOW in industry. As I just pointed out, it began with United States in Hawaii, okay, Japan in 1970. Now right now it had a 7 pipeline, okay, and after 2000, Korea, Taiwan began. I'll talk about Taiwan later, but let's look. The important part is the last column, okay, the sales, the product. Okay. It's about this size. Well, it's not a very big size in terms of when we compare with other parts of the industry, but it's a green, okay, the green industry. So that in the later part of this talk, we'll use Japan's example, which in particular, is very good. We hope it can be a successful, the develop for that. We'll talk about later. So this is the development. So let's look at briefly, in each, the country developed in that area. In the United States, NELHA, which is Natural Energy Laboratory of Hawaii Authority in Kona, Hawaii Island. Okay, this is area view of NELHA. It has this company, Sinotech, which is the largest micro-algae supplier in the world. Okay, and also Kapati farming and abalone growing, and also important is Mackay. There's an ocean engineer OTEC plant. Okay, so it's from energy, food, and some biotechnology application. So it has a whole area. So I went there in 2013 to check it because to look at it, because Taiwan wants to develop this industry. And for Japan, okay, I have a couple slides for Japan because most of it's doing relatively well. Probably not reaching to the peak yet, but we hope eventually it become a very good industry. So it has a total of 17 pipeline in the different area. This spot, and the depth is not really that deep. Okay, it's only about mostly 300 meters, and one up to 800 meters, and that is the cubic meter per day. The amount of water is being pumped up, every day this amount. So this is some are small, some are bigger because it fits its need. Okay, so this is the area. So Japan starts 1989. And the reason doing that is because you want to boost the economy, to serve as an initiator for revitalization of economy, so that they are also the government and also have a private company, okay, laying the pipeline, okay, and to join the industry, okay. One example is the Toyama, okay, use a multi-step. Starting from 2 degrees, and then supply to go 5 degrees at low temperature, and the packet after the factory use a packed aseptic cooked rice, and then the temperature increase to 16 degrees, and then that is good for oyster purification, abalone cultivation part. So we promote, the water had a full chain. So by using this low temperature and clean, okay, the characteristic of the deep water, the Toyama prefecture has made an economic benefit over 7 billion yen per year. Okay. Here's another good example, just Kumijima Island. Okay, Kumijima Island. It has it pumped 13,000 tons per day DOW. It's the largest in Japan. Okay, and both of this has been produced two of the best in Japan. Both of the production of the kuruma, prawn, and the sea grapes in Kumijima Island is the largest in Japan. Okay, and also starting from 2014, there's a 100 kilowatt OTEC plant. Okay, it's mainly for educational purpose, demo purpose. Okay, so DOW has become the most important industry in Kumijima Island. The DOW industry has increased an economic impact of about 2.5 billion yen, okay, every year, and employing about 140 people. Okay. And Japan government moved forward to create so-called Kumijima model. Okay, now it's undergoing. Okay, if you look at, hopefully it can be a self-sufficient island community which provides food, water, and energy, all from deep ocean water, okay, self. So we really, respect, the Japanese government promote, this model, because if this becomes successful, the model can be copied in everywhere, like in Taiwan. Okay, Taiwan has many islands in particular. They can have and we can get a deep water relatively easy. Okay, so this we look forward to it. Okay. So I paid a visit in 2014 to look at this OTEC facility. In Korea, okay, it also starts 2000. Okay. And this all in this is called the Kaohsiung County, okay, in the Gongwang-dao area. This is area. It's all the pipeline and the facility. This is this part. Look at this part. Okay. So it's doing also, making a great effort, and also promote the DOW business and develop rapidly in Korea. And also in China, starting last year, 2017, it also has a deep ocean energy, convention to talk about, the development of the DOW. Okay, and I believe, the area China will also, go into this industry very quickly. So that is about the area which is developing DOW and also its industry. Okay. Now in Taiwan, okay, let's talk about the Taiwan research and development on DOW. Okay, we start the year of 2005. Okay, our government announced a very bold goal of achieving a value of 80 billion, which is equivalent about 7 billion USD. DOW industry by the year of 2015, okay, because in Taiwan, the eastern part of Taiwan is less developed economically. So we have that, the deep water which can use the energy, food, and also many other applications. So that is very good, so our government has, set a very bold goal, as I say. So we have a facility, is set up a facility called Eastern Taiwan Deep Ocean Water Innovation Research Center, and also we have 2 pipelines and 4 pipelines actually doing by government, which is in this area. Okay, this is Taiwan this is the East Coast. So this is Taitung Province, Hualien Province, and Yilan, this area, and the government's facility is sitting in Taitung area. These 2. One is by the Agricultural Council, with a source bank of marine life has been setting up there, and also the Edo Week by Ministry of Economic Affairs also have a pipeline here, and there are 3 private companies. Okay, now it's still under developing, and also it beginning have also some product. Okay, and one now developing into a park. Okay, so this is how it look. Okay, the facility right now is administrative palace. We call the Stone and Source R&D Center, SRDC. It's a semi-governmental financial corporation. Okay, just look like that. Okay. Well, before I talk about that, I would like to have some special, a little bit different from what I have previously talked, a little bit detail about the research. We group a research, I have a small research group. And in the past 10 years, we put efforts to do various part of research, fundamental research on this DOW application. Okay, we have one from the Guanglong Ocean Biotech Company, the VP, and I'm professor from National Taiwan Normal University, major in biotech. And the other one is the National Taiwan University. He's a biomed, he's biotech. And I myself is engineer. I'm doing underwater technology applications. And also, the Mr. Dr. Huang Bin Yi, now actually he's here, an audience. He is the Secretary General of our this DOW, okay? He's a special in marine biology. We have this small group, okay? And I asked this Professor Lee, well, I was the president of National Taiwan University. When I was there, okay, I asked this young professor, to put their effort to do consistent research on this area. And after 10 years, well, he himself is really doing well, doing good. He's starting using the DOW to culture microbes, okay, such as monoscule, okay, such as Antrodia camphorata. Okay, this is not to name. Those are the research result he published in this area, and several papers on the application on this micro, and the other one is on this micro in this, and also have a patent, he get an invention patent or using that, okay. Or lactic and acid bacteria application. It's doing really good for this research in this area. So this is a paper, since I think only 7 minutes, I have to go through fast, okay. So this is the paper on patents. The other professor is also doing very well on the biomed application. He discovered the injection of DOW, okay, can prevent balloon angioplasty-induced hyperplasia, okay, hyperplasia, okay, and also the drinking this, the DOW technique can reduce artery blood pressure and lipid profile, okay. This is, the normal, if you use the medicine to treat, well, this is the bed, it's a lung, okay. And if we use deep water, it can improve step by step, similar to using the medicine, okay, medicine to improve the hypoplasia problem. Okay, so this is a biomedical application, and also many others, such as this one too. Okay, he also earned a patent for the DOW injection at this 12 ppm. This is a different kind of the hardness of the water. Okay, can ameliorate acetic acid-induced duodental ulcer and HP. Okay. Infection. In fact, some also externally find out this, and now he submit the patent. Okay, already get a patent from Taiwan, Republic of China, Taiwan, USA, Japan, and the university. So it's doing, this really good. The figure shows here is that the one without the steps, A is without the increasing the use of the DOW would also suppress the HP, okay, for the ulcer. Okay, so this is also a very good result. Okay, so the application such as this actually is now the group in Taiwan. Okay, now I talk about the major problem encountered. Okay, unfortunately, our problem is very basic. Okay, we encounter the failure of the intake system. Okay, it's because we had this typhoon Okay, so this is a headline last year, and the year before last year. This give us, the very frustrating news that we're spending a lot of budget, but we didn't get a drop of deep water, which is from government part. Actually, the private company also get water relatively well. And we try to analyze, okay, the problem. I'll talk about that a little bit later. And we also reach a very critical point because we only reach about a fraction of the project value, as I just said before, only a very small fraction. So people will become worried whether we should push on this industry in Taiwan because we didn't have a good facility to get from government to get water. Okay, so I began to take over, to gather all the people. When I was president in the National Taiwan University, I began to discuss and try to resolve and ask this specialty from special expert, okay, the expert from Japan, and try to resolve. Okay, and after 2-3 years study, we begin to have this year to have reconstruction of new pipeline. Okay, and besides that, many infrastructure for sustainable development has been developed. Okay, such as I formed a Taiwan Society of the Ocean Water Association, and we have do fundamental research in university, and we do international collaboration, in particular in Japan. Okay, and this is a society, and we also publish the newsletter and to promote this water. And this is signing MOU with Japan, renewing last year. Okay. About the intake engineering, because only 2 minutes, so I just skip that. The major problem is that, we found, maybe due to the failure, which due to the pipeline were caused by the instability of seabed. Okay, but we are not really sure whether that is true or not. But the end up with, the pipe below 300 meters has been buried. Okay, but above 300 meters still okay. Well, I think we made a wrong decision that at the beginning, we have our goal to put water too deep and have pipe too big without have a good experience. After 10 years, right now, we come back, right? We realize we should begin from beginning, okay? Have a smaller pipe, and less is like shallow. And I think, that's okay because we have not done all tech yet, okay? So you don't need a very deep water. So I'll skip all this, this area. And actually, we'll do a research, try to analyze whether that is due to the collapse of the seabed, and do the analysis, processing for this data we get from the sonar, submarine profiler, and end up with analyze an area to see what is the segment. So this part of that is like, in the past 2 years, we try to realize what went wrong, okay? So at the end, we form a new, a line in DOW intake in engineering, okay? And last year, we decide, instead of giving up, we commence a new stage for DOW toward the next decade. I think we have experience. And looking ahead, Japan, I think the cumulative model should be is a good one for us to follow, or to be a good, well, not to say copy, to learn from it. Okay, finally, when you talk about DOW, or you talk about OTEC. Okay, OTEC has a long history of development, starting in 1818, and 2040 there's an Abidjan project, and till 1970, which especially in Japan here, Saga University has a very good facility for doing the OTEC. Okay. And this is the first time, seeing the OTEC tested in Nauru to have electricity to supply to a public school in 1980. 120 kilowatts was generated, okay? And actually only 30 kilowatts available because 90 kilowatts to support the system, okay? In Okinawa, as we just seen that, it had a new, okay, OTEC This is for 50 kilowatt. Its primary role is for research and educational tool, etc. Okay. And here, really like to see the OTEC at work, which is 2015. So Mackay already connected the world's largest ocean thermal plant to U.S. grid. That means it will begin to supply the electricity, and it can hold 100 kilowatts of electricity, enough to power 120 Hawaii home annually. Okay, this is really put the OTEC at work. Okay. And last year we invited Luis Vega to Taiwan, and he's expert in the OTEC, and he said 98 nations is adequate area for the OTEC within the EE zone. Okay, and he concluded the problem is mainly due to financial. Without operational record from a pilot plant, financing of commercial size plant is highly doubtful because each plant would cost $750 million. Okay, so it's coming without a pilot plant. So really, it's a risk now, really, and also depends on the price of the traditional energy too. Okay, so but. Finally, I think I like use this book as my conclusion. This is written by Professor Takahashi. DOW is our next nature resource. He is my mentor in this area because about 6-7 years ago, I met him before I tried to get involved with this DOW, the industry. Okay, and we invite him to Taiwan several times. And this book, this is less than 100 pages, but it's very enlightening. I urge you, for those who want to look at the OTEC, OTEC development or DOW application, can use that. Okay. My conclusion remark is water and energy are among the most important resources supporting human activity, and those two are embedded in and can be extracted from deep ocean. And those are issues I just have pointed out. Some water extraction system, development technology in power, and also in marine culture, and also biotech and health science. Okay, and we think DOW is still our next natural resource. It's very promising resource of our ocean planet, okay, which is our theme of this talk. And this is my self-introduction. Thank you very much.
Thank you very much, Professor Liu.